Assalamu alaikum. In the last video, we have learned the method of conversion of a galvanometer into an ammeter. In this video, we'll discuss the conversion of a galvanometer into a voltmeter. Before going ahead, let me tell you what is a voltmeter. Voltmeter is a device used to measure the potential difference or voltage across a given circuit. How one can convert galvanometer into a voltmeter? To convert a galvanometer into a voltmeter, we connect a high resistance in series with the galvanometer. You know, the galvanometer is represented by this symbol. This is the symbol of a galvanometer. When the galvanometer is connected in a series with a high resistance RH, then the galvanometer gets converted into a voltmeter. It gets converted into a voltmeter. This is a voltmeter. Now, after the conversion, the scale of galvanometer is calibrated in a volt. Okay, remember this. Now, suppose this voltmeter is connected in a circuit to measure the potential difference, and the current flowing through the circuit is I. Then, when it passes through the galvanometer, say the current flowing through the galvanometer is taken as IG. Here, the galvanometer offers some resistance to the flow of current. I take it as RG. No? Remember this. A voltmeter is always connected in parallel to the circuit to measure the voltage. By doing so, it draws current which is almost equivalent to nothing. Okay. A voltmeter should not draw current. If it does so, then the voltage measured by that voltmeter will not be correct. Correct? So here, as the high resistance is connected in series with the galvanometer, so the current flowing through the galvanometer will be equal to the current present in the circuit. So, why is it so? The reason is in a series combination. Now, in series combination or in series circuit, current remains same. What is this series circuit? Suppose you have a component. This is a component. If you connect the second terminal of this component to the first terminal of another component, the first terminal of this component. When the second terminal of the first component is connected to the first terminal of a second component, we call such a combination as series combination. In simple words, in a series combination, we connect the component side by side. Okay. Whereas in case of parallel combination, we connect the first terminal of first component to the first terminal of a second component. That we connect them together this manner. And similarly, the second terminal of first component is connected to the second terminal of second component. this way. If it is so, then we call such combination as parallel combination. I repeat, when the components are connected side by side, we call it as series combination. When components are connected across, then we call it as parallel combination. Okay, this parallel combination, this series combination. This series combination. I hope I have understood. Now we will go ahead. In case of a series combination, current remains the same. If it is so, I can write that I, the current in the circuit, will be equal to the current flowing in the galvanometer. Fine. So the current flowing through RH will also be the same. So in this way, what will be the value of IG? To get this, I am going to make use of Ohm's law. Ohm's law. What is Ohm's law? Ohm's law says that voltage V in a circuit or a potential difference, it is otherwise known as potential difference, in a conductor or circuit is the product of current flowing through the conductor multiplied with the resistance offered by the conductor to the flow of current. Okay, so V is equal to IR. This is Ohm's law. From this, I value can be obtained by cross multiplication. I keep I as such, I bring R this side, so it will divide. So I is equal to V upon R. So in this way, I can write IG is equal to potential difference. It is voltage divided by the total resistance, that is R, total resistance in the circuit. So here, the total resistance, in a series combination, the total resistance can be obtained just by adding them. So I can write IG is equal to V for potential difference upon total resistance is obtained by adding the resistance of galvanometer with the high resistance, RG plus RH. Okay, this I am going to write here. IG equals to V upon RG plus RH. Now, I make sudden changes to this. I write it in this manner. V 1 upon RG plus RH. It is multiplied with V. If I write so, it is not going to make any difference. Now here, this part of this equation, look at carefully. Here one is a constant, numerical constant. RG is the resistance offered the flow of current by the galvanometer, and RH is the resistance of this high resistance. All these three things are constant. They have fixed value. So I'll take it as constant. Now I can write this one as IG equals to constant multiplied with V. So this term is a constant. So I obtained a new equation which appears something like this. Here, when constant is combined with equal to, this can be written as IG directly proportional to V. This shows that the voltage measured by the galvanometer is directly proportional to the current flowing through the galvanometer. So it means that when V increases, that means IG will increase, or vice versa. Yeah. And one thing I forgot to mention here, the value of RH is selected in such a way that the galvanometer shows full scale deflection to the current IG. Okay, it is the selected RH value selected in such a way that the flow of IG, current IG through the galvanometer should show full scale deflection. So this clearly shows that the range of the voltmeter that we have obtained depends on the value of RH. Okay. So this is the value of RH is the deciding factor of the range of the voltmeter that we have made here. Clear? So, one more thing I'm going to find out here. I'm going to find out the total resistance offered by this voltmeter. No, that can be easily obtained as I have shown you here. Total resistance will be called as the resistance of the voltmeter. That can be obtained if I add the resistance of the galvanometer with the high resistance. Okay, this is RV. No, the total resistance or effective resistance. In simple words, it is called as resistance offered by the voltmeter to the flow of current. Fine. So here, as I told you earlier, the range of the voltmeter depends on the value of RH. Clear? So here, here Ig, the flow of current Ig provides full scale deflection. If it is so, I can write that theta, which stands for angle of deflection in the galvanometer, which works as a voltmeter here, is directly proportional to Ig. You understand? If it is so, then according to this relation, theta will also depend on V. Okay. So, the flow of current in the galvanometer shows deflection, which indirectly represents the voltage. This is how the galvanometer works as voltmeter to measure the voltage or potential difference across a given circuit. I hope you have understood. Yeah. Now I will provide some more information about the voltmeter. Here, whatever voltmeter we use will provide some sort of error. Okay. A voltmeter which is free from any kind of error is referred as ideal voltmeter. Ideal voltmeter. No, it is not possible to make an ideal voltmeter. What is the definition of ideal voltmeter? Ideal voltmeter is one which have infinite resistance. Okay, a voltmeter always have high resistance. If the resistance of voltmeter is equal to infinity, then we call such voltmeter as ideal voltmeter. Okay, then another thing you need to know about the voltmeter is always connected in a parallel to measure the voltage or potential difference across a given circuit. And third thing, suppose if you want to change the range of voltmeter n times, then you need to change the value of RH. Okay. In such case, what you will do, the value of RH will be selected in such a way that it is the multiple of the G value is multiplied with n minus 1. If it is so, then the range of voltmeter will vary n times. Okay. So here, this is the value of RH. We need to vary the range of a voltmeter built using a galvanometer. I hope the video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section? Thanks for watching.